Hello everyone, Sean Geringer here, KC0AKY. In this video we're going to demonstrate the various modulation types available on the NPR-70. Now, the NPR-70 is a new packet radio which was described on Hackaday. A kit's available online through electstoreparts.com, and basically NPR is a new set of modulation types that can be used on packet radio for higher bit rates. So we're going to go through. I'm going to start with the narrowest, which is the modulation type 20, and then we'll try the various 2 GFSK and 4 GFSK modulation types all the way up to 24. So right now I have both of them configured in type 20, which is a radio bandwidth of 100 kilohertz. And you'll see that basically our signal in the spectrum analyzer here starts at 433.95 and ends at 434.05. So it's a total of 100 kilohertz. Now let's go ahead and see what type of speed we get. I have a 1 megabyte test file ready. Let's go ahead and pull it down. You'll see in the spectrum analyzer that we are doing a lot more data, so the signal is quite consistent. And this is reported as having a usable data rate of 68 kilobits per second. And we're seeing about that, with it fluctuating but sitting pretty solidly around 6.3 kilobytes per second. Okay, let's go ahead and end that. Let's remove our test file. Let's go ahead and switch our modulation types. Let's switch to 11. Now, if you remember, modulation type 11 is a raw data rate of 71 kilobits per second, and it is a bandwidth of 200 kilohertz. So we notice the new bandwidth right away. Let's go ahead and redo our test file. So it looks like it's coming in just a little bit faster. This is what we expected, 71 versus 68 for the usable data rate. Okay, let's go ahead and cancel that. Now let's go ahead and try the next one, which is 21. Same bandwidth of 200 kilohertz. This time we get a little bit better data rate. Okay, both have been reconfigured. Same bandwidth we still have from 0.9 to 0.1, but our expected data rate now is 130 kilobits per second. Let's see what we get. And indeed, we're seeing right around what we expect, about 12.3 kilobytes per second. We expected 130 kilobits. So about what we would expect. All right. Next one we're going to test. Let me go ahead and cancel this. Next one we're going to test is going to be a little bit more bandwidth, 360. We're going to start with modulation of 12. Both of the radios have been reconfigured. Now, like I said, this will have a bandwidth of 360 and an expected usable data rate of 120. So even though it's a little bit more bandwidth, because we're back to a 2 GFSK mode, actually a little bit less bandwidth. So let's see how that works. Expected was 120 kilobits per second, and we are definitely hovering right around that. Okay, let's go ahead and cancel that. So the next mode, again, we just tried 12. Let's go ahead and try 22. Bandwidth of still 360, but we expect to see 220 kilobits per second. Okay, the radios have been reconfigured. Let's give it a go. Modulation type 22, we expect to see a usable data rate of 220 kilobits per second. And we're seeing just about that. It's sitting at about 21 kilobytes per second. And that's within 360 kilohertz of radio bandwidth. Okay, let's stop that. Let's try setting modulation of 13. Now 13 is another 2 GFSK, bandwidth of 600 kilohertz. And the actual usable data rate is less than what we had in 22. But we should see the additional bandwidth here in the SDR. Should be seeing at 13 a total of 600. So 433.7 to 433.3, indeed we do. And we should see a usable data rate of 190 kilobits per second. Let's see what we get. Yeah, indeed we are. Right around that. A little bit slower than we had in modulation 22. Let's go ahead and end that. Now let's go ahead and try the modulation type 23, same 600 kilohertz, but we gain a lot of bandwidth. We have a usable data rate of 330. On modulation type 23. Let's go ahead and test it. And we are seeing maybe a little bit less than expected. We're seeing about 23, 24 kilobytes per second. A little bit less than the 330 that the documentation says we should get. Notice it seems to be maybe having some issues. Okay, so the next mode that we're going to try will be the widest bandwidth. We'll start with the 2GFSK 14. That should be a full megahertz wide. So we'll be going from 433.5 to 434.5. Let's go ahead and test this out. Now we expect to see about 300 kilobits per second. A little bit slower than we would expect. It seems to be really struggling to even get over in the 20s. Certainly not consistently. Okay. That leaves one remaining modulation type, 24. Still at 1 megahertz wide. We can expect to see 470 kilobits per second. Well, this is interesting. It doesn't seem to be wanting to connect. Make sure both are set. No joy on 24. Can't seem to get it to connect. Fall back down to 23 and see if we can make them work. Okay, they're connected again. Let's test it, and then we'll try 24 again and see if maybe that was just a fluke. To my eyes, the performance of the 23 just does not seem to be quite as good as would be expected. Okay, let's end that. Okay, we're going to try this again. Set modulation 24. Definitely strange behavior. Now we're generating a signal. It's not the right bandwidth. So it does seem that, at least to an extent, 24 does not seem to work. Rebooting both of them now. We'll see if that makes a difference. Okay, we're connected. We're back at 22 now. Let's just make sure everything's working. Oh, looks like it's still connecting. So I guess the findings of this, certainly the modulation 20 falls within the specs for amateur radio use in North America. Has a radio bandwidth of 100 kilohertz and a usable data rate, which is slightly better than 58 or 56K that's available on other packet modems. But we were able to demonstrate at least up to the 3 times 3 successful connection. With the 4, we did have some issues. Might be a bug in the firmware, or it might be an issue with the distance that I have these radios apart. So that's been a demonstration of the various modulation types. In our next video, we'll do some more demonstrations of some distance that we can use the NPR at the various modulation types. Thanks for watching.